Ah, wonderful. As presenters, when we give many different talks, we try not to choose favorites, kind of like with your children. You can't choose a favorite child in your family, right? But this talk is my favorite. So I'm so glad you're here today because we're going to be talking about mean architecture. Now, I'm one of the meanest guys you'll ever meet. Do you believe that? No, of course not. We're talking about MongoDB and Express.js and AngularJS and Node.js. What we're really talking about is just a very modern way to do web development. So, as we said, my name is Scott Davis. I run a consultancy out of Denver, Colorado called ThirstyEd.com. I also run the HTML5 Denver user group. And so these are concepts that are very near and dear to me. And this talk in particular is going to be far less about implementations, what I call curly braces and semicolons, and more about big thoughts. These are the kinds of things that you can't copy and paste from Stack Overflow into your application. But these are the things that are so important for us to recognize as web developers. Because the architecture is the stuff that's hard to change later on. And so we want to think about architecture not only at the beginning of the project, but throughout the project. And what we find is if we focus on architecture, the implementation details get less interesting. Whether you're dealing with Angular 2 or Polymer or AMP. That was the first I had heard of AMP. What a really interesting project out there. But what we'll begin seeing are commonalities emerge, like web components are going to be a big part of this presentation. Because whether you're dealing with AMP, you probably noticed all those AMP elements you can use in your website. If you're using Polymer, you probably notice all the Polymer elements. And if you're using Angular 2, you're building your own elements. So what we're going to talk about here are a number of high-level concepts, things that should transcend any particular implementation, but really get you thinking about what web development is going to look like for the next decade or so. Are you ready to get started? Wonderful. Let's do it then. I have a couple of videos on O'Reilly. I'm an author, but apparently only old people like me read books anymore. All the cool kids are watching videos these days, right? And so now I'm shooting videos for O'Reilly. The architecture of the mean stack is one that has been very popular moving forward. I shot it last year, and it's already terribly out of date. But don't worry, because I have a whole new series of videos on O'Reilly, and many of these videos you can watch the first hour or so for free. And if you have an O'Reilly Safari account, you can watch the entirety of these videos for free. So I encourage you to Google them, look for them online, because there's a lot of good free content you can get. But this whole series of videos I'm shooting now for O'Reilly, they call it a learning path, because it's a whole series of related videos. And we've been calling it On the Road to Angular 2, because Angular came out in beta in late December of last year. And so we've been tracking Angular. Have you been working with Angular 2? Have you been following through all the betas? I can tell because you're bruised and bleeding and battered, right? It's been a very rocky road seeing Angular go from beta to release candidate. It just went final yesterday. Angular 2 is now officially final. It's ready for you to be using. And so a lot of what I'm going to talk about here today in this presentation, as well as this longer form set of videos online, are the technologies you need to be familiar with in order to be successful with Angular. Because these are very significant changes. And again, architecture is the stuff that's hard to change as you move forward in a project. Libraries and implementation details are easy to swap out. But what Angular 2 represents is not just a new implementation. You can't just swap out a script source of Angular 1 and drop in Angular 2 and expect to be successful. Everything has changed because the underlying architecture of web development has changed. So that's what we're going to talk about here. Even if you never write an Angular 2 app, these kinds of things should be deeply interesting to you. And if you want to play around with this online, I encourage you to go to meaningfuljs.com. Meaningfuljs.com has code that you can download and play with. Because it's one thing to see code running on someone else's laptop, it's another thing to get it running on your laptop. I've been a teacher for over 25 years now, so very many times I feel that working software on your computer is the best way to learn. And so I put together a number of projects like this. And Meaningful.js is just a way for you to get started with Angular 2 in a hands-on kinesthetic learning style. All right. So, you've seen a lot of old man presentations on stage. We had an old man keynote this morning, because 40 is old, isn't it? He'll be dead soon. Yeah. If you've seen Scotty present, he was talking about being a selfie programmer yesterday and about what an old man he is. I don't see Scotty here, but we were laughing over dinner last night and drinks about how we've all got more white in our beard than we'd like to admit. And so this is my version of the old man presentation up here. Enjoy yourself. Because last year, 2015, was a very important year in web development. There were a lot of key changes that will have long-term ramifications, 10-year long-term ramifications of how we do web development. But in order to understand these changes in 2015, we have to go back 20 years to 1995. This is the old man portion of the presentation. Are you ready for this? Yes. Oh my gosh. Last year, 2015, I celebrated my 20th wedding anniversary. So, thank you. I didn't do that for the applause. I did this as a cautionary tale. Look at what 25 years in the industry will do to you. I'm literally twice the man I used to be, right? Yes. So it's not too late to choose a better career, because this is what you're going to look like after being in our career for many decades. But this 1995 year was important to me, not only because I met the love of my life, Kim, I also met the love of my technological life, Windows 95. This was my first professional writing credit as well. I was at the Windows 95 release event. Are any old people in here willing to admit what they remember when Windows 95 came out? Yes. Jay Leno was the MC for this event. The Rolling Stones came and played live. People lined up at midnight to install an operating system. I remember this date so fondly because Windows 95 came out the day before I was married. Now, my wife doesn't like it when I describe it this way. She likes saying we got married and Windows 95 came out the day before. She doesn't like it when I lead with Windows 95 when I tell that story. But she gets her roses every year, so it all works out. As a matter of fact, that's been my affectionate nickname for her. When we got married, I called her Kim 95. And then she was Kim 98. Kim ME was a rough release, wasn't it? That wasn't very good at all. But now she's El Capitan. She likes that nickname a lot. She says, we'll stick with El Capitan for me moving forward. So Windows 95 was a watershed year. Excuse me, Windows 95. 1995 was a watershed year. We have many watershed years. And change can sometimes be difficult. It can be scary. And this is a personality trait you have to realize. You either have to embrace the change and the fear of the unknown, or you have to be afraid of the unknown. This is on the Thomas Jefferson Monument in Washington, D.C. And I know the font is pretty small, so I blew up the important parts of it here. I said, I am not an advocate, this is Thomas Jefferson speaking, I'm not an advocate for frequent changes in laws, constitutions, and web frameworks. Again, the text is very small, but trust me, it's there. Yes? Thomas Jefferson says, I don't advocate for frequent changes in web frameworks, but they must go hand in hand with the progress of the human mind. JavaScript takes a lot of heat. We laugh about, 0 days since the last JavaScript framework was released. Yeah. But Angular 1, which is regularly ranked the #1 framework out there. It jockeys back and forth between Backbone and Angular 1, but Angular 1 tends to win that battle more often than not these days. Do you know when Angular 1 was released? 2009. 2009. We're sitting here in 2016, only now talking about the next release in this framework. So Angular has been a remarkably stable framework, and we like that as developers. We like being able to invest in an API and grow with it over time. And so when things change, and Angular 2 represents a significant change, it can be scary. But Thomas Jefferson says we have to embrace this change. It must go hand in hand with the progress of the human mind. And later on at the very bottom, he goes on to say that we might as well require a man to wear the coat that he wore as a boy than to require a civilized society to remain ever under the regimen of their barbarous ancestors. Wow. I mean, I kind of liked Windows 95. Does it feel like that was one of our barbarous ancestors? No, I hope not. But things do change over time. So in terms of watershed years, let's first go back to 1995, because that's when Windows 95 was released. But more importantly to our discussion here, that was the year that Netscape Navigator 2 was released. It was the first very popular web browser. Back in 1995, it had over a 90% market share. And back then, we used to pay money for software. Have you ever paid money for a browser before? I didn't think so. Yes, the man with the white in his beard raised his hand. I keep trying to contact Netscape Navigator and ask for a refund. They won't answer any of my emails. Why do you think that is? Oh, that's right. They're not in business any longer. But stay tuned, because we have a discussion about that as well. But what's most important about 1995, we had a brand new operating system, and we have a brand new web browser that ushers in a brand new era of software development. And Netscape Navigator 2 was significant because that was the first browser that introduced us to JavaScript as well. Brendan Eich was the programmer that Netscape hired. They hired him to bring Lisp to the browser. What a different world we'd be living in right now if we were all Lisp programmers, right? But in fact, Lisp became LiveScript, which eventually got branded JavaScript, not because JavaScript has anything to do with Java, but in fact, when Netscape Navigator Beta was released, it was called LiveScript, but in between the beta and the final release, Netscape formed a strategic alliance with Sun Microsystems, and they renamed LiveScript to JavaScript. I said this joke yesterday, but I love these jokes. I love the sound of my own voice. You might have heard this before, that Java is to JavaScript as ham is to hamster. That should give you an idea of how related Java and JavaScript are to each other. JavaScript was unknown. Brendan Eich only spent 10 days building out this programming language. That's not enough time, is it? But what we saw was just the glimpse of something interesting. A zero installation future where you could visit any website and have functionality that just appeared on your laptop without running any kind of setup.exe at all. And the other thing that was very important is this worked across platforms. It's like the web did. So all of a sudden it didn't matter if you had Windows users or Linux users or Macintosh users. All of them could have the same user experience simply by visiting a URL, 0 download, 0 install. That's a pretty compelling story. And we're still feeling the ripples of that bomb that dropped in 1995, which we call the web. So 1995 was an interesting year. 2005 was also an interesting year. Here we are 10 years forward now. And all of a sudden, we aren't talking about Internet Explorer anymore or Netscape Navigator. In the 10 years, Netscape has peaked and crashed and burned and gone out of business. But that was the year, 2005, that an open source browser was introduced to us. Firefox. Mozilla Firefox. Do many of you know that Mozilla Firefox is actually an open source implementation of Netscape Navigator? They said that Netscape failed as a company. They went out of business. They were acquired by AOL and went along. But then all of a sudden, what we got out of that failed business was an open source browser, a profoundly influential open source browser. As a matter of fact, Firefox was codenamed Phoenix during development because it was a project that had risen out of the ashes of a failed browser. So we had our first significant, serious, technologically interesting open source browser. But what was more interesting in 2005 is that we not only had an open source browser in Firefox, we had an open source render kit called WebKit. A browser really looks monolithic from the outside, but under the covers, it's nothing more than a render kit and a scripting engine. A browser, in fact, needs to display HTML and CSS. That's what the render kit does. And it needs to execute JavaScript, which is what the scripting engine does. So when we look at something like Mozilla Firefox, the render kit was called what? What's the render kit called in Firefox? Gecko, of course. Yes, after the lizard. And then what was the JavaScript engine called? SpiderMonkey. Yes, SpiderMonkey. So Firefox itself is made up of Gecko and SpiderMonkey. So where does WebKit come in? Well, it's an open source render kit that was included at the time in mobile Safari and desktop Safari. Mobile Android browser and desktop Chrome. It was included in Blackberries. It was included in Kindles. I worked for several years for Time Warner Cable where we built out a smart TV app in HTML5 and Backbone. All of your Samsung smart TVs have WebKit browsers in them. All of your Sony PlayStations have WebKit browsers in them. All your LG TVs and Samsung TVs and Panasonic TVs all have WebKit browsers. So Netscape Navigator at one point had a 90% market share. It was the #1 browser. Several years after that, Internet Explorer had 90% market share. It was the #1 browser. For a period in the late 2000s, WebKit was the #1 rendering engine on the planet because it had its feet in both mobile browsers and desktop browsers and smart TVs and everything else. And this was entirely open source. So we could say that 2005 was simply the first year of the open source web revolution, but it goes beyond that, doesn't it? Because that was the year we were introduced to AJAX, Asynchronous JavaScript and XML. A consultant just like me named Jesse James Garrett coined this phrase because it really isn't a particular technology. If we want to get detailed about it, it's really called XHR, isn't it? The XML HTTP request object. Do you know who added XHR? Microsoft did, exactly. Internet Explorer was the first browser to give us this ability not to do coarse-grained macro request responses where the entire page refreshed, but it did micro request responses. Microsoft introduced this technology for Exchange, which was their web product at the time. For their online browser-based mail client, they wanted the ability for new messages to come into your inbox without having to do that coarse-grained request, refresh cycle, and refresh the entire page. And while we take that for granted now in Gmail and Yahoo Mail and everything else, a much better way to remember 2005 and the AJAX revolution is a little mapping app called Google Maps. That was the first year that Google Maps came out. I was working on the Google Maps project, not with Google, but with a satellite imaging provider in Denver, Colorado called Digital Globe. If you flipped over to satellite view and zoomed in on your backyard, chances are those were my bits that you were looking at. I loved working on pre-release Google Maps because the mapping app before that had the #1 market share was called MapQuest. Do any of you remember MapQuest? When you would pan the map, when you wanted to pan north, you would click the up arrow and the entire page would refresh. If you wanted to go east, you'd click on the east arrow and the entire page would refresh. MapQuest was a Web 1.0 way of dealing with web mapping. Google Maps was a Web 2.0 way of doing it. It was all predicated on AJAX. They were little 200 pixel by 200 pixel tiles. And you had on-screen tiles and off-screen tiles. And as you dragged your map, we called it a slippy map. Yes, as you dragged your map, all those offline pixels came online, and then we made AJAX requests to fill up the offline buffer again. Incredibly elegant. And that absolutely capitalizes on what Web 2.0 development looked like in 2005. Small micro request response cycles that were going on in open source browsers. And the math works out so perfectly, except for Apple. Darn it. But boy, 2 years later in 2007, the first iPhone came out, and that changed web development as well, didn't it? Now we have websites that are almost exclusively mobile-based. Instagram has over 95% of their traffic coming from mobile devices. Twitter, over 75%. Facebook, over 2/3 of their traffic all come from mobile devices. So we can see this second era of web development was also profoundly influential and radically different than the first 10 years of web development. Yeah? But we're here to talk about 2015. It may seem like it took us a long way to get here, but it's really important for us to understand the march of time, the progression, because these represent not only changes in libraries, but fundamental changes in the way we're going to architect our web apps as well. So last summer, 2015, we officially had a ratified specification for HTML5. Now what's interesting is I've been doing HTML5 development since 2009. The browsers have been rolling out HTML5 features for years. I've been running HTML5 Denver for as long as I've been coming to Bangalore, 7 years and counting now. So how on earth were we able to ship production websites in HTML5 when the specification only was finally ratified last year? Well, it's interesting, isn't it? I'm good friends with Brian Getz. He's the lead architect on the Java project. He's the father of Java these days. And this kind of discussion drives him crazy. Because he says, you know what Java 9 is going to be? It's what I say it's going to be. And do you know when Java 9 is going to be released? When I say it's going to be released. And do you know when you can begin using it all together now? When I say you're ready to use it. Now, Brian Getz is a great guy. I'm telling this story for comedic effect. He is not a dictator like that rules with an iron fist. But the point is, he does all of the work, and his team does all the work, and you are presented with the final version of Java. JavaScript works exactly the same way, except everything is different. What happens is browser vendors begin implementing new features. And like Microsoft, they said, we got this cool thing called XHR. We're going to roll this out. And then Mozilla saw that and said, that's really cool. I think I'll make a completely mutually incompatible version of that. Yeah? But at least we got it out there. And then over time, as these implementations compete, the W3C, the World Wide Web Consortium, comes in after the fact and says, I think this is how we'll standardize this technology and move forward. They even discuss this in the HTML5 specs. They say this explicitly. They say our job is to pave over the cow paths. I love that. That's very evocative, isn't it? Especially to read it in an RFC. Our job is to pave over the cow paths. It's incredible to think that we would put an implementation out before it had been tested and proven in the wild. But that's exactly how most software works. They release a new version and then we discover all the bugs. They release a new version and then we discover the benefits and the drawbacks. What if we reversed that process and worked through the benefits and the drawbacks and got battered and bruised and nicked and cut? But when we finally released a specification, we knew that it was a solid version of that technology. That's how the web works. Brian and I laugh all the time. I say, yeah, the way versioning works on the web, it only works in practice. It doesn't work in theory at all. But that is the case. So last year, we finally got a new version of HTML5, 7 years after I started using it. But that's okay. We got a new version of JavaScript as well. If you were here in my talk yesterday, last summer we got ES6, ECMAScript 6, a radically new version of JavaScript that gives us lets and consts and fat arrows and promises and most importantly classes and modules and imports and exports. It radically changes the way we do JavaScript development. It's been out in a browser for over a year now. We had new versions of CSS as well, but more importantly, we had an entirely new version of HTTP. HTTP is the hypertext transport protocol. It's the way we get HTML and CSS and JavaScript from the server to the browser. We have been using HTTP 1.1 happily since 1997 with only a minor rev in 1999. So for almost 20 years, we've been using the same transport mechanism, and last year we got a brand new version of it, HTTP 2. If you've been using any Google projects over the past several years, Gmail, YouTube, anything like that, Hangouts, you've been using HTTP 2. They called it Speedy, SPDY, but Speedy was their spec that they threw over the fence to the W3C and eventually got ratified as HTTP 2. So what 2015 represented is a whole new way to describe your HTML, and a whole new way to add behavior to your web apps through JavaScript. And oh, by the way, a whole new way to transport it to a browser. Because HTTP 2 is not a request response cycle, what I affectionately call a one and done. No, HTTP 2 is connection oriented. It's streaming now. No more cookies because you have an always-on connection. And if you have an always-on connection, your server can begin pushing resources to you before you ask for them. Imagine visiting a web page, and on the home page, the web server pushes all the images and CSS and JavaScript you'll need for page 2. So it's already there before you request it. That's HTTP 2. And it's out and in production right now and has been for over a year. So we look at something like web components, which you're going to see brought up over and over again through this presentation. Web components came very close to being finalized last year as well. And web components are a way to not deal with divs and spans, generic elements, but building your own elements into HTML. And if you're using Polymer, you're using web components. If you're using AMP, you're using web components. And in fact, if you're using Angular 2, you're using web components as well. So, profound changes that dropped last year. And all of the libraries were revved as well, but they are based on these new changes. When we saw Node.js, it went 1.0 last year, and by 1.0 I mean 4.0, and by 4.0 I mean 5.0. It's complicated, isn't it? Yeah. But Node.js, the easy thing for you to remember are the even-numbered versions are like Star Trek movies. They're the good ones. Yes. So Node 4 came out, which was their stable, their long-term release, and then Node 5 was released simultaneously with all their experimental changes. Well, several months ago we got Node 6, which was the new normal, which was the new stable version, and then they're working on experimental versions in 7. It's much like the Ubuntu numbering model as well. But we had a new version of Node.js that embraced all the changes in ES6. We had Material Design and Polymer, 2 new frameworks that both went 1.0 last summer, and they embraced these new web components. and HTML5 that we've been talking about. And yes, right under the wire in December of 2015, we got Angular 2 in beta. And Angular 2 embraces all of these changes. You've heard me say it many times. If you look at Angular 2 and get scared by all the changes, you shouldn't be scared because it's not Angular 2's fault. It's just reflecting all of the underlying platform changes that came along. So you can see 2015 is a very, very important year in web development. This really did change everything. And it didn't change everything in 2015. What it's going to do is change everything in 2020 when we finally embrace all these new technologies. But you're the smart ones, right? Who here is the smart one? Of course, everyone, hands need to go up, right? Yes, you're here now learning these technologies because they're ready and waiting for you. And these are the technologies you should be using in greenfield development moving forward, because this is what web development is going to look like moving forward. You've got some decisions to make, don't you? Is Web 2.0 deprecated? Can you no longer make AJAX requests? Can you no longer use last year's frameworks? Can you no longer use Angular 1? Well, of course you can continue using that. Take the blue pill. You'll forget this talk ever happened. You'll wake up tomorrow and you'll be doing exactly what you've been doing for the last 10 years. Does that sound appealing? I hope it doesn't. I hope you'll take the red pill and join me on this exciting stuff moving forward. So we're here to talk about the mean stack. And mean stands for Mongo, Express, Angular, and Node. It's a way of describing the kind of websites you build, but this is mean 1.0. Mean 2.0 ends up looking something like this. It's still Angular, but now we have Angular 2. And Angular 1 was a very popular framework. Angular 2 is not, let me repeat, not a drop-in replacement for Angular 1. You're going to have to really radically rethink the way you're doing web development. Now, how many of you are doing Angular 1 development right now? Good, good, good. How many of you are writing directives in Angular 1? You're going to be okay. Your move from Angular 1 to Angular 2 is going to be an okay transition because directives were optional in Angular 1. They're required in Angular 2. It's all components all day long now. And so a lot of my clients said, love me some Angular 1. How do you feel about directives? No, thank you, sir. Which is fine. They're going to have a hard time upgrading to Angular 2. As a matter of fact, if you're already using directives, you can begin cherry-picking various libraries like the router, like various aspects of Angular 2, and they've backported them to Angular 1, but only if your architecture matches what Angular 2 expects your architecture to be, which is a component-oriented architecture, not a page-centric architecture. We'll talk more about that in just a moment. We're still using Node, but you'll notice I've misspelled Express on this slide. I love Express.js. It's a wonderful web server, but you know what? They are tightly coupled to HTTP 1.1. They're having a hard time upgrading to HTTP 2 of the way they've architected their library under the covers. So you're forced now to either upgrade to HTTP 2 using a different web server or wait until Express updates itself. And they've publicly said that we're having a hard time doing it. The way we've written our framework didn't lend itself nicely to swapping out the underlying transport protocol. So we are evaluating at my company Koa, which is the entire Express.js team have left the project and started a new project called Koa. And Koa 2 is ECMAScript 6 out of the box and HTTP 2 out of the box. It's a very strong candidate. We're also evaluating another framework called Happy. Happy.js, H-A-P-I out there. We're really impressed with Happy. Good, strong documentation coming out of the Walmart organization, the Walmart mobile team. So Happy is another one as well. But both of those frameworks are being used, both of those web servers are being used because HTTP 2 is a must-have for us. And we need to have a web server that supports it. You'll notice I also misspelled Mongo up on the slide, didn't I? Pouch. DB is an interesting one because Mongo is an outstanding NoSQL server, but that's just it. It's a server. It's a server-side solution. And in this new progressive web era where we want offline support and synchronization, PouchDB has an amazing offline synchronization story that Mongo simply doesn't. So you'll see our mean stack, we have a few misspellings in there. The underlying implementations have changed, but more importantly, it's because the architecture has changed. Now, progressive web apps are something you're going to hear an awful lot about. There's a whole laundry list of what it means. But at the end of the day, what this means is progressing from a fundamentally browser-based experience to something that represents fundamentally a native experience on mobile devices. Imagine going to a website and the first time you visit it, it says, "Hi, I'm in a browser with URLs and back buttons and everything else." But maybe the second time or the third time you visit this website, they say, "Hey, you seem to be coming here a lot. Would you like to upgrade your user experience? Would you like to have an icon that you can tap off of your home screen? Would you like to have more and more of our assets cached locally so it'll be faster over time?" That's what they mean by a progressive web app. It'll progress from a browser experience to an app experience, and it'll do it in a seamless way. So I know this is a lot of homework, and I apologize. But if you are going to be doing Angular 2 development, these are all the kinds of things you should get familiar with. And if you're not familiar with them, you should get familiar with them before you write your first line of Angular 2 code. Because Angular 2 assumes that you have all of this under your belt, that you're comfortable or at least conversant in HTTP2, that you're comfortable or at least conversant in this idea of offline and client-server synchronization, this notion of moving from a request-based architecture to a streaming-based architecture. A lot of changes underfoot. I'm excited about it. And most people say, "Oh, this is just because you're a contractor, right?" No, I'm excited because we are sitting here now at the precipice of what the next 10 years of web development is going to look like, and it's going to look like this. And for where I'm sitting right now, it's kind of exciting. So, we're talking about this mean architecture. And once again, if we want to understand what mean 2.0 architecture looks like, we got to understand what mean 1 looks like. And in order to understand the value proposition of mean 1, we got to understand LAMP. Now, LAMP, of course, is Linux, Apache, MySQL, or PHP, or Perl, or Python. But the most important thing about the LAMP stack is architecturally, it's all server-side. Everything is up on the server. The web server, your web app, even your database. With mean 1.0, we began to distribute that a little bit. MongoDB is probably going to be running server-side. Express is going to be your web server running server-side. Angular is going to be running client-side. But we begin sharing a lot of that responsibility between servers and clients. And that's a big step in the right direction. Because now we're in a SPA era, a single-page app era, where some people are even talking about serverless architectures. So we can see that pendulum is swinging from entirely server-side to distributed client-server to maybe completely serverless if you go entirely with a SPA architecture. But this architecture, once again, is so important for us to understand. The implementation details can change, but fundamentally we need to understand what a 1995 web app looked like and then a 2005 web app looked like so we can really appreciate what a 2015 web app looks like. So in a LAMP, in a Web 1.0 scenario, we had multiple pages. We would set up individual HTTP GET requests. We would get each one of these pages. It would download, render, and we would see pretty pixels. Now, with single-page apps, they're well named because instead of downloading individual pages, what you're doing are showing and hiding individual divs. Everything is already there locally, but we are showing and hiding those divs based on the clicks. A subtle but important change to the way you architect your app. Now this lamp stack, once again, the browser box is completely empty. It's because when we send up a request from the browser, we've got a server-side router that receives that request. And that server-side router hands it off to a controller, which pulls it out of a server-side database, which puts together your model and your view. And then in what I call the baby bird model, it puts the entire web page back on the wire. So your baby bird at the other end, your poor little browser there, just has to swallow whatever the server hands down to it. This was appropriate at a time when we had Motorola Razors, right? Little postage stamp-sized browser windows out there. Flip phones, yeah. But we're in an era now where we're carrying quad-core processors in our pocket. We have a lot more horsepower on the client side, and so we should begin taking advantage of that. It puts less data on the wire. It improves the user experience because local resources always, 100 times out of 100, will render more quickly than a server-side resource, right? If it's already there, you've already won the race. So how do we get that to happen? Well, our request now typically stays client-side, which means we have a client-side router, which means we have the full MVC stack on the client side instead of the server. And notice all this is local. We haven't invoked a single HTTP request. That controller might decide that she has all the data she needs in order to display a full page. But if she doesn't have the data she needs, she'll send an AJAX request. But you'll notice what'll come back on the wire, not an entire page with images and CSS and everything else, just the data. Pure model so that it can be rendered client-side and eventually we show the div with that data there. Architecturally very different. Same design patterns, model view controller, but where those elements live really changes the way we architect our app. Here's another subtle but important difference. If you've got a page-centric worldview, here's the deal. How many of you use Jquery? That's a silly question, isn't it? #1 most popular Java library on the planet by a long shot. Jquery is a fundamentally page-centric JavaScript library. It's meant to sweep your entire page and style all the paragraphs. Sweep your page and style all the images, or all the links, or all the form elements. Anytime you're sweeping the page, anytime you take this page-centric approach, you're taking a very Web 1.0 approach to solving that problem. This is pseudocode, but if I wanted to build out this page, I would build out all those menu categories, and then I'd build out all the main elements on there, and then I would baby bird the result down to my browser. Nothing wrong with that. But if we take a more component-oriented view of that page, the page doesn't look any different to the end user. But from the developer's perspective, you're not sweeping the page for all paragraphs or images or links. You're doing up a couple of new components. Give me a new sidebar. Give me a new movie list. And you might be saying to yourself, well, wait a second. Where are all the implementation details, right? Exactly. This is encapsulated now. You don't care anymore. If you've done Google Map development in the past, you have loaded JavaScript up into the global namespace with a script source. You've loaded CSS up into a global namespace. You're sweeping the page to bring all this stuff together imperatively. But if you take a new component-oriented approach, you say new Google Map. You don't import additional JavaScript. You don't import additional CSS. All that is encapsulated in the device. You declaratively put a new Google Map element on your page, and the rest just happens. Very different way of approaching web development. And so how do these components communicate with each other then? We want our components to be highly cohesive, but we also want them to be loosely coupled. And so the way they communicate with each other, every time you click on one of those menu items on the left, it'll fire a new event. And you'll have an event listener that'll be registered for that event, in our case, that main view over there. And every time you click on a new menu item, it will emit an event that we will then listen for and respond to accordingly. And whether you're using WebSockets or Angular 2 or Backbone, all of these web frameworks are predicated on this event-driven model. And so it's hard to talk about component-oriented development without also talking about asynchronous development, because those two tend to pair up very nicely. Now, I've been dipped in synchronous programming my whole life. So when I look at code like this, I'm like, oh, I feel great. I'm going to drop a stone at the top of that function, and I know that when I call get menu items, nothing is going to happen until that method invocation is done, and then I can paint my sidebar. And then when I call get movies, it's going to block synchronously until I have all my movies in hand so I can paint out the page and move forward. I love this model because there aren't any surprises, right? You do line 1, and then line 2, and then line 3, line 4, and then baby bird the results down the wire. Asynchronous programming gets a little more complicated. Most people say, oh no, look at all that. But once you get used to this pattern, it works really nicely. So what we're saying is, hey, guess what? When someone clicks on view movies of type, show me comedies, sci-fi, romantic comedies, Pixar movies, right? What it's going to do is generate an AJAX request. That's that movies.query. And then we have a promise. We're going to wait for that request to come back, and only then will we manipulate the data, and notice we will emit a new event. This is Angular 1. But then that other component is listening for that event. So on change main view, when that event is thrown, which means I have all the data, I got new data, I'd like you to display it, we turn around and display it based on that event-driven asynchronous way of doing things. Again, very different architecturally. So if someone tells me about Angular, I say, oh yeah, I love it, man. It's single page, client-side, component-oriented, asynchronous. It's buzzword compliant, isn't it? It's got all the features I'm looking for. And that's Angular 1. So when Angular 2 came out, I said, I'm really excited, right? Meantime, this is great, because Angular 2 is also single page, client-side, component-oriented, asynchronous. So I said, oh, this will be an easy change, right? The implementation is very different, although architecturally it's very similar. We've been through this already, that if you've already been using directives in Angular 1, your move to web components will be easy because architecturally they're the same. If you haven't been doing directives, it's going to be a harder step. But Mean 2, let's focus on that name now, Mean 2.0. Yeah, it's fine, but it seems kind of tired, doesn't it? It seems kind of played out. We have Web 2.0 and Scott 2.0 and all these 2.0 kinds of things. That doesn't really kind of capture how exciting these changes are, what big changes are coming down the wire. I mean, these are fundamentally game changers. We have a new version of HTML, a new version of JavaScript, a new transport, and a whole bunch of new libraries that are taking advantage of all these new underlying capabilities. Just calling it 2.0 doesn't seem like it really captures the magnitude of change we're talking about. So I got a great idea then. We'll just call it Web 3.0, right? Does that help? No, not really. Because again, when we were talking about Web 2.0, we were talking about moving from MapQuest to Google Maps. That was a big, radical change. By calling it Web 3.0, does that really signal that same big, radical change? Yeah. How about this? Now, a lot of times when it comes to naming, remember yesterday, that's how I started my keynote? Naming is hard. It's really hard for us to think of good names. So bad names are easy to come up with. So many times I'll come up with an awful name that at least describes what I'm trying to convey, even if it's not catchy. And so what I'm trying to describe by Mean 2.0 and Web 3.0 is a new progressive peer-to-peer platform. But that's a lot of P's, isn't it? And P4 is no better than W3. Yeah, when it comes to this. But at least let's walk through this line by line. And maybe we'll come up with something we like before I run out of time. We've talked about these progressive web apps really taking us from a browser-based experience seamlessly to an app-like experience. And we have things like service workers now, so we can get notifications. We have HTTP2, so we can push. So a lot of those things that would sway us from a mobile HTML5 solution to a pure native solution, either in iOS or Android, those lines are getting blurred now. Progressive web apps allow us to do a lot of those things that might have bumped us over the edge to a pure native experience. Again, a lot of interesting aspects behind this. This is a Google initiative, but it seems to have fairly broad-based vendor support. And again, you might say to yourself, well, where's this specification? Well, we just have one vendor right now that's pushing an implementation. Once we start seeing a second vendor and a third vendor, we wait for the Microsofts and the Apples of the world. Once we start seeing a consensus like that, we're kind of paving over the cow paths. We're very early days, but no one is actively objecting to this. Google is ahead of the pack, but all browser vendors have signaled that this progressive web app stuff is something we're paying attention to, and we'll end up implementing it. We'll implement it. I think this is a pretty safe bet right here on this progressive nature of web development. So if we move from progressive to peer-to-peer, a lot of P's, right? But if we move to this peer-to-peer play, this, I think, is maybe the most significant of the changes. This, I think, is what's most radical. How many of you use GitHub back in the office? Look at all those hands go up, right? How many of you used to use Subversion? A lot of hands go up as well. Subversion is to Web 1.0 as GitHub is to Web 2.0, in so much that we moved from what was primarily server-based. Yes? Your single source of truth was that server repo somewhere. You were only borrowing the truth temporarily, and you would check the truth back into the server. With GitHub, it's now completely distributed. We have multiple versions of the truth. We're in the multiverse right now. Because who has a version of that project on their laptop? You have a version of that project on the laptop, the entire version. And I do as well, and you do as well. And we all manage those changes back and forth. Again, it only works in practice. It doesn't work in theory. But does GitHub work? Absolutely it does. Absolutely it does. So what if your database worked just like GitHub did? Rather than having a single source of truth like a big Oracle database up in the sky, or for that matter, a big MongoDB up in the sky, what if we had a fully distributed database? Databases that were running on the client and the server, and not just the client and the server, but all the clients and all the servers, and they're constantly replicating and synchronizing and sharing state. What if you went into airplane mode and had the full database on your mobile device? And as you were making changes to it, they were full fidelity changes. And when you got out of airplane mode, those changes were synchronized. Can you do that with email? Absolutely. I've got a long series of flights. I've got 24 hours of air travel I look forward to that starts tonight at 3 a.m. and gets me back to the United States. And I'm going to be doing a lot of email jockeying. I'm going to be completely offline, but I'm going to be deleting messages and moving messages to folders and creating new messages. Can I do that in offline mode? Absolutely. My email client caches up all those changes, and the next time I get in, IMAP starts synchronizing all the folder changes. SMTP starts catching all the new messages as it goes up. I've got a great offline experience. I've got a great airplane mode experience. Why can't we have that with databases as well? We can. PouchDB. PouchDB. Angular Universal is a project that I find incredibly fascinating, because what this means now is you are going to have the full version of your app running on the server as well as the client. The first time you visit a website, your Universal Angular app can serve up a pre-rendered version of that page. And because we're using HTTP2, it can be pushing not just resources, but a synchronized version of that app down to your browser. And so then all of a sudden your app is the Heisenberg app. It's running simultaneously in the browser and the server and synchronizing state. Now, I just got done talking about that in terms of a database, but now I'm talking about your actual application with its application state. When you hear universal, sometimes people like talking about isomorphic JavaScript, which means it's JavaScript that can run equally well on the browser or the server. Well, universal is what we're talking about now. We mean the same thing. This is an Angular app that runs equally well on the server and the browser and shares state. I find it an incredibly interesting app because all of a sudden now, and we've got to what I think I like best, we've gotten to third wave web architecture. Because what we have now is the entire app running on the server and our entire app running on the browser. And if we have a persistent connection between the two, we can synchronize state and run these things wherever we have the most CPU cycles and whatever is going to render it most quickly. This is what I think web development is going to look like for the next 10 years. This third wave web architecture. So where does that leave us? Well, we've talked about progressive and we've talked about peer-to-peer, but what about platform? How many of you use Twitter Bootstrap in your project? I love me some Twitter Bootstrap. Twitter Bootstrap gives you the same user experience across browsers, doesn't it? It allows you to give you the same look and feel across Safari and Chrome and Edge. It allows you to have the same user experience across smartphones on a 4-inch screen and tablets on a 9-inch screen and laptops on a 15-inch screen and smart TVs on a 60-inch screen. That's a responsive web app because it responds to the size of the device that it's on and adapts itself accordingly. But when we're talking about platform plays, we're talking not just a consistent look and feel across browsers. It may be hard to see, but this is the browser version of this app. This is the Android version, and this is the iOS version. If we end up using something like material design, which I'm going to talk about this afternoon after lunch, material design is like Bootstrap++. Because not only does it give you a unified browser experience, it gives you a unified cross-platform experience. You can have the same look and feel library that runs in browser, in iOS, in Android, yes, even in a desktop.NET C# app. We're evaluating this right now. I'm coming in right now to an organization that has a 15-year-old desktop app written in C#, and we're rewriting it all in Angular 2 and Node.js and all this fancy-pants new technology. And when we release our new web UI, what's it going to make our desktop app look like? The state-of-the-art 1990s desktop app, right? And so one of the things we're evaluating is using material design on our new fancy pants Angular 2 web app and just refreshing the look and feel on our .NET app. It's not being tricky. We're going to add new functionality as well. But what we're doing is unifying the user experience across platforms. And we're in an era where we can do that now. There's a wonderful project out there called Angular Material. It's still in alpha right now. We're this close to deciding to use it in production because it's actually quite stable. But Angular Material would give you the ability to incorporate all those material design components directly into Angular 2. So where does that leave us? I'm not wild about the name, but definitely wild about the promise of this particular technology stack. A progressive, peer-to-peer platform is what we should be aspiring to write for the next 10 years. And we have the frameworks that will allow us to do this kind of thing. And these frameworks look new and scary, but it's because they are embracing the underlying changes that are already in our browser and have been there for years. So if you have been waiting for HTML5 to be standardized, it has been. If you're waiting for JavaScript 6, ECMAScript 6 to be standardized, it has been for over a year. If you're waiting for HTTP2 to become a major player, it's here. And what we have to do is embrace this watershed year that just happened last year. It's not too late. If we embrace these technologies and hit them now and early, we can have that same 10 years of leveraging this new way of doing web development. We can settle in and find the best practices and get the longevity that we had with Angular 1, that we had with AJAX, that we had with the whole Web 2.0 experience. But 10 years is an incredibly long time, isn't it? And we're at that inflection point where we are kind of done with the previous 10 years of technology and looking forward to the next 10 years. And I am quite excited about what the future holds. Mean 2.0 is quite an exciting opportunity for us. Did you enjoy yourself? I did as well. Thank you so much for your time.